Hi guys, welcome back to steps 3 of the 4-step framework for system design interviews. Going to continue with our example about like YouTube or video sharing streaming platform system design. Now that at this stage we should have our high-level design and a very solid component and the design for the topics we are given. So the YouTube or video sharing. It's time to deep dive into key components to ensure we meet the non-functional requirements. So especially around scalability, availability, performance, reliability, etc. Be prepared to answer some tough questions at this part, because this would be the one where you can demonstrate like your experience, knowledge, and skills, how to deal with a large distributed system. Key focus areas in deep design. Normally, like it would be handle millions of users at least at a bit of a date. So about like horizontal scaling, about like data storage, about partitioning, how do you handle scaling? Like for SQL database, it's about like coordinating on date persistence strategies. And also for NoSQL, most of the time it's like we are having that by default about the horizontal scalability, but it's nice to point those out and also focus on design trade-offs with every decision you made for each component, and also for storage strategies, efficiently storing, accessing videos, caching, partitioning, those type of things, latency, and also if you're expert in the recommendation system or search system, you can go deeper into those areas. But if you're not, we can stay at the high level. Um, Caching is like a very popular topic as well, mostly about like caching strategies. You need to know there's a cost for to use caching and then different caching strategies. So let's go through each component. On the CDN side, there isn't much to further introduce. So CDNs will be at the location close to the user. It'll be redirected, it'll be serving content from those locations using the streaming protocol and also with adaptive streaming. That's the most important thing. And for object storage, it's two-part. Either we can use existing component provided by third party, including cloud service or other providers, or we can build it in our own. It is not like an easy task. It is complicated. You can justify your reasoning for using third parties, easy to use, even though that's a cost. And probably if we are building our own, it won't be costing much less, or you need to do like further evaluation or investigation in this case. And also there's maintenance overhead. You need to make sure it is for long term and petabyte of data. So it might be more efficient if we are using third-party storage services. And so for message queues, I think that's straightforward enough. Some popular ones like RabbitMQ, the queuing system. I should make sure like we can separate out the concerns we can scaling each part on request, like producer or the consumer. And some challenge on the worker side is about the complexity of parallel processing. We need to have like a coordination services like etcd, Zookeeper, or Console for this to make sure there's one brain like to control this, and you can have workers to do the actual work, and then you can assemble everything and put that back to the object storage. Then for the upload service, it manages two parts. First, when the upload request comes in, it will be responsible for to generate a pre-signed URL back to the user where they can upload videos directly to the storage instead of like through the upload service. That would reduce the overhead and the complexity for the upload service. And also, yeah, it will be making more sense as the final storage will be on the object storage set as well. This should be horizontally scalable as well. Everything is stateless. And we can store video metadata. I think we covered that. Maybe just for clarity, list it out. Structured data, a good candidate for SQL and also for query. We can query the data as we want to find like tag, like author, time, etc. It's much easier with like SQL database. And for then we need to consider, we need to cache any part of the metadata. There could be, you can justify like if there are any use case where we can use the caching for fast access. That's most likely. But for me, I'm not an expert, so probably this depends on the use case. If we need, that's not a difficult or complex job to have like a caching upfront, the permanent storage, and also for reliability and availability. Yeah, we have already covered about the replicas, about the sharding by keys. I think that would cover well on the upload side. And then for the search side, yeah, again, should be horizontally scalable. We build the index with Elasticsearch or some other search services. We use workers to pull the data from different source. I think mostly metadata. We don't need like user profile or anything because it's mostly search by content by author. It's all like included in the metadata set. We can read directly from the read replica and for the Elasticsearch to build the index and serve the content. One thing maybe you need to point out, we can do this like at a predefined frequency and every hour, every 2 hours, every night. And also there will be like popular or hot topic. How do we build that in? Like we can have maybe a separate thread or separate process to build based on hot content. If any search items reach, say, 100,000, we can trigger that a special flow to build the index for that purpose. And then for to serve popular search result, we can put the result into caching or the fast uh, storage like Cassandra or DynamoDB. Instead of like calling the cache a search service, we can check if it's included in the cache. And also it's search responsibility. If see some threshold on the search query, we can save the result in the caching and there's typical considerations for caching strategies. We won't repeat that here. Then the last part is for the view service, like to get the content from the recommendation service. Again, there's a two-part for logged in users regularly visited. We can build the more personalized recommendations, both that are viewing history. I kind of covered that. And then for non-logged in users, we can recommend something based on popularity on the region or any information we have. I think that's details about the recommendation service, what kind of like feed they need. But for the recommended service, it's not working by magic. It definitely needs some input feed to create result. I think that's pretty much it. Like even for API gateways, we can have like a hot master and hot standby or horizontal scalability for that as well. Everything else is the same. But using session management like Redis, it's a popular choice to store user session data to create horizontal scalability and even for caching, like we can have distributed caching strategies with same as data storage like replicas, sharding by keys, and also we can use um, consistent hashing to locate the data quickly. So I think overall that would be a solid design for a video streaming service. Now at this stage, like that could be possible questions coming from each area. then you need to just deal with them directly, and then refer back to say to check if you have covered all the areas together with the interviewer before you close this off. And also, it's nice to suggest further consideration areas like monitoring. How do you know like system health, and how do you make further improvement based on business data, system data, CI/CD pipelines, security, compliance. These are topics, given the time constraints, you won't be able to cover. But it's nice, like in real time, real production scenarios. And then I think the most challenging part is done. The next step would be like for you to have time to do a final walkthrough and have the opportunity to ask questions from your side. See you in the next video.